Okay, we're going to talk about matrices, and just like we had organized data on a spreadsheet in class, this time we're going to organize our data in a matrix. And a matrix is just an array of variables that has rows and columns, okay? And it's important that you remember it's always rows and then columns. So every time we talk about the rows and columns, rows are first, columns second, okay? So imagine a spreadsheet, but without the lines in it. Okay, so we're going to have is something that looks a little bit like this. We tend to put it in brackets, okay, and then we'll fill in this with rows and columns of numbers. So 2, 3, and 1, -4, 5, and 6. So they can be positive or negative numbers. They don't have to be whole numbers. It's just easy for me. So this is an example of a matrix, okay? There are 2 rows in this matrix, and there are 3 columns in this matrix. Therefore, we call this a 2 by 3 matrix. Okay, so see how we always list the 2 first, the rows first, and then the columns. So when you're asked for the size of a matrix, or the order of a matrix, that's the 2 by 3. Okay? And it's very important which one comes first. The 2 is the rows, the 3 is the columns in this case. And rows come first. Okay, now let me explain it one more time about the importance of rows first, then columns, because we also refer to elements within the matrix, okay? So if you're asking for elements, this 3 right here is an element. Okay, it's just one number that's a part of this matrix. But we're going to name the element, and let's start by naming the matrix itself. So the matrix, let's call it A. And matrices are typically done with capital letters. So we use capital letters to name the matrix itself, and then we're going to use lowercase letters to name the elements. So this element 3 is going to have a name little a, but we have to say which element it is. So we're going to tell you which row and then which column it's in. It is in the first row, so there's the 1 for first row. It's in the second column, so there's 2 for the column. So this is element A12. It's not a 12. It's an A12 because we're giving you the row and then the column. Those are called subscripts. When you have those little numbers, they're written below the line, okay, but they're attached to the letter little a. Okay, here's a new matrix B, and I want to do a couple of things. Number 1, I want you to tell me what is the size of the matrix, and then I want you to name what is B23 value. What do you think? Okay, so when I look at this and I look at the size, I remember I have to do how many rows. Let's see, 1, 2, and 3 rows. And then I say how many columns, and there are 2 columns. So this is a 3 by 2 matrix. And I'm looking for the element B23, so that's going to be in the second row. So that's this one. It's going to be in... yes, I made a mistake. I shouldn't have asked for B23. I should have. Let me ask a different one. Let me ask for B21. Alright, so what do you think B21 would be? We'll just go ahead and keep going. B21, it's got to be in the second row, and it's got to be in the first column, so that intersection is 4. So the number 4 lies at the position 2, 1. Alright, so that's a matrix, and that's elements within a matrix and how we label them. Okay, so what do we do with matrices is we like to organize data, just like we were organizing data on a spreadsheet. So imagine a spreadsheet without the labels. Alright, there are certain things we can do with our matrices once we've created them. One of the things you can do is you can add or subtract them. So let's say I had 2 matrices. Okay, so I have a matrix A and a matrix B. You'll notice they're both size 2 by 2. Okay, and that's important. To add or subtract, the matrices must be the same size. So that's something you're going to want to remember. If I had matrices that are not the same size, I would not be able to add them. And the reason is, when you're adding matrices, it's very simple. And you just add them element by element. Okay, so first row, first column. Oops, try this again. A plus B would equal, looking at first row, first column, this one and this one. So we're going to say 2 plus the negative 3 in that first row, first column entry. The second entry, let's see, the first row, second column, so this one and this one will make up the first row, second column result. And we're going to do that with all the entries. So let's go to this second row, first column, and this one are in the same position. I'm going to add them together, 1 plus 5. And finally, let me go back to this one and this one. They're in the second row, second column position, 3 plus 1. So as you can see, it's very simple. You're just adding the element with its corresponding element. So, and then I'm just going to figure it out. Is equal to, it's going to end up being a 2 by 2 matrix in the end. I started with 2 by 2s, I'm going to end with 2 by 2s. I get negative 1, 4, 6, and 4. So super easy. We love this sort of just adding with matrices. So let me give you one to try. Here are two matrices. I want you to name the size. Make sure they're the same size. And if you can, then you would find A plus, well, let's do A minus B. Alright, so take a minute and see what you get. Alright, when I work it all out, remember I'm subtracting negative numbers, so it all turned into addition, and they all added up to 6. So I have, this was a 3 by 1, 3 rows, 1 column. Both of those are the same size, and that's the size of my answer. Okay. We have to talk about some other things we can do besides adding and subtracting. So the next thing you want to think about is multiplication. And here's where things get a little different from matrices. There's different kinds of multiplication. So the first kind we're going to learn about is called scalar multiplication. And you should be wondering, what the heck is a scalar? And it's just a number. Okay, so for right now, we're going to say this is just a number. So it's not a matrix, okay? It's not a vector, okay, which is a special type of matrix. And you don't even know what a vector is yet. So don't worry about it. It's just a number, okay? And what happens is we're going to take a matrix. Let's say we had one that was, let's do another 2 by 2, 2, 0, 5, negative. Oops, already I got this. So let's go -1, 3, and 6. So here's a matrix A. It is a 2 rows and 3 column matrix. And I want to find 3 times A. Okay? So what happens is, what you've got is 3 outside this matrix. 2, 0, 5, -1, 3, 6. And here's where it's super simple. Okay, all you have to do is distribute the 3 to everything inside, just like we did with parentheses and the distributive property then when we had, plus sign between every term. We don't need a plus sign between anymore because these are individual entries. They each get times 3. So very simple then. 3 times 2, 6. 3 times 0, 0. 3 times 5, 15. Second row, -3, 9, 18. And that's the answer to my scalar multiplication. there was only one matrix involved, and the answer is the same size as the matrix that we start with. Okay? So you can go ahead and try this one. I've given you a matrix B. You might want to identify the size of that, and then find negative 2B. Okay? I'm going to pause it and we'll come back with the answers. Okay, it was a 3 by 2 matrix to start with. That's the size of my answer. You can see how I just distributed to every element within the matrix, and that's what you get. Okay, and just the very last thing I have to talk about is if you have a whole string of operations to do, multiple operations, then you just want to make sure you're following PEMDAS like you would any other time with algebra. So you're going to do your scalar multiplication first, followed by any addition and subtraction, and everything goes from left to right, just like it did before. So I'll leave you with one more problem to try. I'll give you a couple of matrices. A is equal to negative 5, 6, and 2. We have 3, negative 8, and 9. Let me give you a second matrix, B, and that second matrix, 12, 5, 5, negative 4, 4, negative 7. And I'm going to ask you to find negative 6B plus 7A. So just be very careful, because of course if you make one little, arithmetic mistake, it's going to show up all the way through. Okay, so let's check when we're done. Alright, there's the numbers I got. The first thing I did, of course, was take negative 6 times B here, and then I took 7 times A here, and then I had to add the two matrices together. Lots of places for me to make a careless error. Hopefully we agree. If not, we'll have that little argument when we get back in class. See you soon.